Hi, in this video we'll be looking at a nice problem solving idea. So without any further delay, let's just get into the problem. So the problem says that you need to find the answer to Q queries on a static array A of size n. So a static array means the values of the array don't change. Now the Q queries are of the form question mark LR. So for this particular query, given L and R values, you need to find the sum of elements in the range L to R in the array. Okay, so you'd be given an array A with values in it, and you'd be given Q different queries one after another, and after each of the query you need to tell me the sum of the range L to R. Okay, so if we just quickly look at an example, we have question mark 2 4. So question mark 2 4 means sum of the elements in the range 2 to 4. So that is this range 3 1 minus 5, right? This range, and this is actually equal to minus 1, right? This is equal to minus 1. What about this question mark 0 to 4? That is this whole range from 0 to 4, right? This 4 2 3 1 minus 5. So if we find out the sum of this, okay, if we try to find out the sum of this becomes 5, right? So a lot of such queries keep coming, and you need to tell me the result of all of the queries one after another. So how can we do this? So one obvious way to do this would be, for every query, just loop from L to R and find the sum of the elements. That gives you an answer in order n, because the L and R can actually span the whole array, and in that case you might need to traverse the whole array, that on the worst case. So that would take you an order n. So for every query we can solve this in order n by just looping. So for every query you can solve this in order n, right? And so the total time complexity of the whole problem would become order q times n, right? So now, how can we do better than this? So let's get into the idea of the problem. We try to build a pre-computation array, or array P, okay, such that we try to keep P of I, the array index P of I, okay, stores the prefix sum of array A. Okay, so what does this prefix sum mean? So at a particular index I, this will be the sum of the elements that end up to I. So from 0 1 2 3 up to 3, so you keep that up to 3. So technically speaking, this is just this P of I would be equal to summation of I equal to, sorry, j equal to 0 to I A of j, right? So this is what we are storing in P, and we can build this P array pretty easily, because if we build it in the forward direction, what we have is we can just put the first element as it is. So let's just directly put the first element as it is, because there is only one element. The next element is the sum of these two elements, so that is 6. The next element is sum of these three elements, so that is 9. The next element is 10, right? And the next element is 5, and the next element is the sum of all these elements, right? So now, one way to do this is, like, for every element you add up all the prefix, but then again the sum of number of elements that it contributes to. So for every I, you need to sum over I elements, right? And if you take the summation over all of such elements, if you iterate on the A array, that will give you an order n squared solution, because for every index I, it can take you on a worst case order n. Every element needs to be contributed to that. So the sum of all that for all elements in P would be order n square. But we can build it pretty easily using the relation that P of I is actually equal to P of I is actually equal to A of I plus P of I minus 1. Why? Because P of I minus 1 holds the sum of all the elements till I minus 1, right? and then if you add a of I, that's just p of I, right? Because that's what p of I defines. You just add the last one more element to this, and then this extends the p of I to p of I plus 1. So if you just need to find this element, you can just add this and this, so you can just get the value as 11, so you don't need to iterate on the whole array. And in this way you can create the prefix array. Okay, now how is this prefix array going to help us? So let's say this is the array and we build the prefix array for it. Okay, let's say we have built the prefix array for it, and let's say we want to query this 2, 4. Okay, so we need to find the sum of this 2 to 4 range. Okay, so we obviously know that this can be found using adding these 3 elements, and that is -1. One more way we can use to find out this value is we can use this element and this element. How? Now this element over here stores the sum up to this range, right? Like this range in the original array. This 5 is the sum of all these elements. This 6 is the sum of these 2 elements, right? These 2 elements is stored in this 6, and these 0 to 4 is stored in 5. So if we subtract these 2 values, if we subtract this smaller range from this larger range, so these elements gets cancelled out, right? These elements get cancelled out because they were there in the blue range, but then if you subtract the white one from the blue one, these elements get subtracted out and only these elements remain. And that is exactly what you need to find the sum of. Okay, so what we can do is that we can just, for 2, 4, we can just look at 4, that is this 5, minus, we can look at the index 2, but not up to 2, we just look at 2 minus 1, 1, because the 2 element will be included, right? So if we see at index 1, it removes the contribution of all the elements from 0 to 1, so you are left with only 2 to 4. So this 5 is the sum of elements from 0 to 4, so this is like sum of elements from 0 to 4, and then you subtract this value at 1, that is 6, and that is like the sum of elements from 0 to 1. So you basically remain with the range 2 to 4. This is what we are doing. Okay, similarly if I go on with this query 1 to 5, okay, so 1 to 5, this is the whole range. So you just find out the fifth p value, that is this, because you need to add first everything up to this last element, this 5 that is given in your query. So that is this 11, you look at 5, and then when you need to subtract the values less than 1, you just go 1 before 1, that is 0, and then subtract everything below that. So you subtract this value from it, so you take -4, and that is exactly equal to 7. For this 0 to 4, we know that this stores the answer for 0 to 4, right? This stores the answer for 0 to 4, so you can write this right away 5, you don't need to subtract anything. So in case this last element is 0, we know that whatever this stores, this 4 index stores, is actually from 0 to 4, right? So you don't need to subtract anything, so you can directly write the answer for 5. Okay, so that's the whole idea. Let's just quickly generalize the idea. So if you are given any query for L2R, how do you get that from this prefix array? So we can find that quite easily using the expression prefix sum up to R, that is from 0 to R, and subtract the prefix sum of 0 to L minus 1. So that will leave the elements of L, L plus 1, L plus 2, so on up to R, and this will give you the correct sum that you require. Okay, so what we are doing when we need to find the sum of elements in a range L to R, we convert this A array into a P array. So you build an auxiliary or a pre-computation array that you would be using further. So you build this pre-computation array using the technique we discussed, that P of I, this P of I is equal to A of I plus P of I minus 1, and that is a linear time operation. So you can create this whole array in the linear time. Okay, just a one loop throughout the array, and for every index you just need the value that is in over here and this over here. So if you are computing from the in this direction, you don't need anything else apart from these and these values. So that's pretty easy. So you will be able to build this p array in order n, and once you build this prefix array, now when you need to query this value, this range, you will get that in order 1, because it's just 2 array access, right? 2 elements of array needs to be accessed, and just subtract them and you get the answer. So that's just order 1. So once you build this prefix array, you can get the answers for each of the query in order 1. So that if you talk about the time complexity of the approach, it takes first of all n, that is to pre-compute the prefix array, and then for every query you need order 1, so you just multiply it with 1, so that doesn't matter. So it's order n plus q, right, for the whole problem. So this is the idea of something called prefix sums. So a lot of problems actually reduces to using prefix sum in some variants. So this is a very useful technique, and whenever you need to find out some range sum or range properties in some static array, the one thing that should strike on your mind is that it might be possible using a prefix sum. So the prefix sum can be used in sums, right? You can find out sums of ranges. You can even find XOR of ranges. So XOR of ranges can be found using prefix sums. Okay. So any element operation that for which you can remove the contribution. So what are we doing over here? We are removing the contribution of 0 to L minus 1 from this, right? In XOR as well, if you XOR again, it removes the contribution. So whenever you want to remove a contribution, if the operator supports that, then you can use prefix sum to solve that problem. Okay. So that's all for this video. Thank you, and see you in the next one.